Question of the Week from the Naked Scientists.
Hello and welcome to Question of the Week from the Naked Scientists with me, Diana O'Carroll. This week, pull up a peeler and take a potato.
Okay. Hi, this is Neil from Villa Tersland in Switzerland. I've been listening to the podcast for a while and I've got a question for you. Why is it that a potato peeler doesn't need sharpening where every other kitchen knife does?
So what's so special about the humble utensil? It turns out that it doesn't need sharpening simply because it doesn't need to be sharp.
Yes, this is Tony Atkins. I'm Emeritus Professor of Engineering at the University of Reading. There is something called the critical crack opening displacement, which means how much have you got to stretch the end of the crack before the crack will carry on propagating. If you're using a knife to get rid of the skin or peel, then you have to wedge open the material at the end of the blade, at least as much as this property called the crack opening displacement. And I was surprised to discover this magic displacement that you have to achieve for potato is actually much bigger than you would have to do for meat or cheese. Now, the implication of that is that to cut meat, certainly, and cheese, you really need something very sharp. Whereas with potato, because this value is big anyway, you can say that, well, why bother to have something which is sharp?
A potato peeler doesn't need sharpening because it still works well even when it's blunt. But there's also something about the angle of cutting which makes using a less sharp tool even easier.
What is much more interesting about cutting is the whole business of why, if you take a knife, however sharp it is, you can cut. But it is so much easier if you introduce some horizontal reciprocating motion. That turns out to be a very, very interesting problem that I've solved. And it goes like this, that if you say cutting something requires work to do it, which is 4 times displacement, and you say, okay, well, if I put a bit of working sideways, then clearly I won't require as much work pressing down. That is true, but when you do the sums, you get a strange non-linear coupling between the forces, meaning that the slightest horizontal movement reduces the vertical force considerably. And that's why it's so noticeable. And what this also goes on to is that it means that the overall forces required to cut are less if you have this sort of slice and push together. And that means that you don't damage the surfaces that you cut. And that can be very commercially important if you think of buying salads or something containing melon in a supermarket. The normal way of cutting them, you damage lots of cells adjacent to the surfaces that you've cut, and these weep out liquid. So the shelf life is improved if you do the cutting properly.
Peeling horizontally requires less effort than cutting vertically down into a substance in many cases, so a peeler doesn't have to be as sharp as other knives simply because of the way it's used. On the forum, Lamprey5 said there's not much in the potato to blunt the knife, such as minerals, which only comprise 1.1% of a potato. RD mentioned that some blades are self-sharpening, as they have one harder side, meaning that the other side wears away faster to maintain a narrow edge. Next week, on a slightly larger scale...
My name is David, and I'd like to know, how do we measure the distance to the nearest star?
How do we measure the distance of something that distant? Answers to Chris at thenakedscientists.com or write on the forum, and that's at thenakedscientists.com/forum.
Question of the Week is part of the Naked Scientists podcast and supported by the Wellcome Trust and UK Fast. Look us up online at nakedscientists.com.